Hello everyone, welcome to Proof of Concept channel. As part of the POC today, we are going to see linear regression model building and then deployment the model using the Flask-based framework. Following are the steps involved in this process: loading required libraries, import the datasets, univariate analysis, bivariate analysis, model building, model analysis, save the model as a pickle file, load the model to get the prediction using the test data, Flask-based API setup, and simulate the input data using the Postman, get the predicted output from the model. Let me go one by one. For the step 1, load required libraries. We need following these libraries: pandas, numpy, and then the linear regression we are using sklearn linear regression. Also the datasets, we are using the sklearn datasets, load Boston, and saving the model we are using the pickle libraries. Let me quickly run this. It's done. Okay, for the step 2, we are going to import the dataset. So we are using the load Boston. So it's a housing dataset. So as part of this objective is we will be given this 13 attributes. Using these attributes, we are going to predict the price of the house. So here, if you see, all these are the data, and we have the target variable price. So we are going to see, if you provide all these data, what is the output from our model. So what is the housing price predicted based on these independent variables? That is the objective of this POC. So as we see the shape of the data frame, 506 and 14s, we have 14 columns, including the target variable, and then we have 506 entries. Similarly, if you see, provide the Boston dot descriptions, so that provides all the description of the records. So you can see the attribute information here. So especially CHAS, the Charles River dummy variable, 1 if it's tracked found river, 0 otherwise. Similarly for the room, average number of rooms per dwelling, and the age proportion of the owner occupied units built prior to 1940. All these data sets. So you can get familiar with all this attribute information here. And then if you do just Boston data frame dot info, that will give us how many entries we have, and what is the data type, and then if we have any null values. Here we are not seeing any null values. That's the reason we are getting all the count is equal to 506. No null values in the data sets. Similarly, if you see um, the mean and the median value of the attributes. So here, if you see, the mean and the median value of Knox is 0.55, and similarly, average number of rooms per dwelling are 6, and the minimum value is 3.5, and the max is 8.7. So you can see here the mean value, average value, also like the median value 6.2, and the max 8.7. All this analysis you can do using this. Similarly, you can see the count also, the record counts. It's showing that 506 records. Let me quickly see if we have any null values presented. You can use these commands to check any null values. As we already know that we don't have any nulls, and this is the alternative approach to check if we have any null values. So all our data sets has 506 entries. We don't have any null value presented at this moment. So the step 3, we are going to do exploratory data analysis. So we are going to see some analysis based on the given data. Let me see first, check for the unique columns. So we can see all the unique records, unique columns available. So the count of unique columns as well as the details. Similarly, I'm doing a kind of analysis here using the building age. I'm seeing that more than 140, more than 160 owner occupied units built before prior to 1940. So that's the count it's showing here. So this is part of analysis. I just took like three attributes and I'm doing some analysis, but you can take any of the attributes and do more analysis based on this. This is kind of a sample, but you can take any attributes and then do some perform some kind of analysis. Based on this chart, so we are seeing that uh, chas has most of the value equal to 0, which means most of the places have no tracks bounding river. Similarly, this chart, it's a pupil teacher ratio. So here we see that it's skewed to the left, which means number of students per teacher is higher in most of the areas. So that's what this graph is representing. So here we are using SNS.parflat for the bivariate analysis. So when you do the bivariate, we see like a number of good observations based on that. One is the Knox value is Knox concentration in air and price. The more the concentration of the Knox in the air, the less the housing price is. So when you see that Knox and then the housing price, so we can able to see that there is a negative correlation here. Similarly, for the room, when you look for the um, room and the price, if you see there is a positive correlations, which means number of rooms will be increased, the price will be automatically increased. Rooms are less, then the price will be automatically decreased. Those kind of linear regression, linear relationship we can identify and analyze using this pair plot. I given some of my observations here, but we can find more observations. So this is just a sample only, but we do have a lot of other observations as well. Similarly, when we plot using the heat map, we can clearly see if you see the Knox and the price, so minus 0.43. Similarly, for the room, you see the the positive correlation 0.770. The correlation details as well as the observations given as part of these steps, we can go through and then see these observations. So we are in the step 5 right now, model building using the linear regressions. So here I'm splitting the target variable and the independent variable separately. So the x is only for independent variables and y is the target variables. So I'm keeping the y as a price. So that price is our target variables. We are going to predict the price from here. And this step, I'm doing the try and test split because we need some portion of the data for testing it and some portion for the train. So if you see here 70-30, we can do 80-20 also. Nothing wrong in it, but I'm using 70-20, 70-30. And so you can see the train test splitted the x and y values 70-30 basis. So this step, we are building the model, so the linear regression model, and here we are fitting the trained data. Now, if you see our model is ready, so the model is ready to predict the values. So here we are performing few more analysis. So the step 6 for the model analysis. So here we are seeing the R square. R square especially is a goodness of fit for the measuring the linear regression. So we can see how much score are we getting from here. The more score that we get, that's good for the model. So I'm seeing that the train set I got 0.71, which is not great, but for this POC that's good enough. Like we are just doing the sample here. This is this model we are not going to deploy into production. So we are good with these numbers. And for the test data I'm seeing that 0.78. That's the score we got it. And so this step we are going to see the coefficients. So these coefficients especially indicates of the relationship between a predicted variable as well as the response variable. So the positive coefficients, so that will increase the value to the target variable. So whenever we see the negative, that will be decrease the target variable value. So if you see here the NOx concentration, so that's a negative value, minus 21. This will reduce our target price as well. If you see the room, so we are seeing the positive. So whenever the room increase, the housing price also increase. So this will be the positive coefficients. Those kind of analysis we can perform using these coefficients. And so we are in the step 7 right now. We are going to save the model as a pickle file. So why we are using the pickle here is, so we are thinking using the pickle file we can keep the model separately. We can save the model and then deploy this model as a production based application. From there we are trying to use the API and trying to get the prediction. So that's the reason we are pickle.dump and saving this model. So this is the step to save the model, and the name of the model is mylinearmodel.pickle file. I'm just loading here in this step to get the prediction out of it. And similar way, I will explain more about how we can deploy this model based on the production and use this model as a API and then exposed, so we can directly call this API and get the prediction out of it. So that step will be coming. Also, I'm planning to make a small video for that purpose alone, how to save the model, how to deploy the model, and how to make the model as a API so that we can call that API in the real time and get the prediction. So that will be available soon for you guys. So now we loaded the model. So our model is available, loaded model variable. And so here we are going to, we are getting the predicted price. So if you see it, this step is very important. So we see all the independent variables and absurd price. Absurd price is the one, it's available in our data set, the Boston data set, and predicted price is the one our model predicted. So when you see here for all these records, absurd price is 2.8 and the predicted is 3.2 and 2.9 and 2.7. So this is not exactly match because we see that we got less score with our model when we use the train and test data. But this is the result, like, so we are close near to the result. So some of the records, if you see 16.7 and 17.8, but yeah, that's the output from the model. So we are in the step 9. So here I'm just doing the setup, Flask based API setup, and how to save the model and expose as a API. So this step is available for you guys to take a look into that. So here we are using the model, like the load model. So we are just saving the model as a pickle file and providing all the input attributes here, and afterwards we are just invoking as a API. So in this step, if you see, we have a local host and the get prediction method. So this is nothing but the Postman. We are giving the input to the model, and from there we are getting the output. So if you see here, this is the input to the model, and we are getting the predicted price from the model. So we are getting 23.07 as a response from the API. So this is the way, like in real scenarios, like the production based applications, we'll be deploying the model and then exposed as an API, and through that API we'll be getting that predicted values. So we are in the summary right now. So as part of this POC, we loaded the Boston housing dataset, which is given by sklearn. It's a free dataset, free to use, and we did like some portion of explorative data analysis and model building, training, and analysis. And we saved the model locally as a pickle file and loaded back the model to get the prediction from the model. And so we see like a Flask based API setup and access the model prediction through the API using the Postman. We see that the Postman given the response from the model. So That's all from this proof of concept. All these steps are available for you. So this notebook is available. I just given the link below, and you can utilize it. So the objective of this proof of concept is you need to like get familiarized with the linear regression model and how to deploy the model, all those steps. All these steps are reproducible. You can just use Colab and just follow these steps. All these steps are reproducible and you can able to get the prediction from the model. Thank you so much for watching. We'll meet again in another POC shortly.